Welcome to another AQA AS Chemistry video. Today I'm going to be doing a video on the mole. We finished the first section of physical chemistry. Now we're going to be going on to the next part, which is going to be more about amount of substance. And the first topic on that is the mole. And the amount of substance is measured using a unit called a mole. What's a mole? A mole is simply, or if you are to give it by equation or by a number, a mole is approximately 6.022 times 10 to the power 23. This is a rough approximation of it, but for what you need in the exam, that's what they'll give you in the exam, and that's what you need to know. If they say otherwise, then use another number, but it's pretty much 6.022 times 10 to the power 23 atoms within a substance. So within 1 mole of a substance, there's that many atoms within that 1 mole of a substance. Alright. But it could be molecules as well. If it's a molecule like a methane, it's 6.022 times 10 to the power 23 units of that. Or so if we're talking about methane, for example, it will be 6.022 times 10 to the power 23 methane molecules of that substance. You should have covered this generally in GCSE, but you know, in case, just quick refresh, that's what it is. Alright. Carbon 12. The value of a mole is set so that 1 mole of carbon 12, also 1 mole of a carbon 12 atom weighs 12 grams. This is important as the mass of one carbon 12 atom is 12 atomic mass units. That's what AMU stands for. 1 atomic mass unit, or in this case, the atomic mass unit usually uses the MR. So mole converts between atomic mass units and grams. So 1 gram is equal to 1 mole times by 1 atomic mass unit, which would be the what is for carbon 12, or the mass in this case is equal to the moles times by the MR. And that's kind of, this is how we generated that equation. Convenience. It's difficult to measure weight of an atom as it's so tiny. By using the mole, we can do calculations about the amount of substance we have in any reaction. Avogadro's constant. So Avogadro's constant, as I said before, is approximately 6.022 times 10 to the power 23, and that's the unit. That's the number that you're going to use for your exam by that many significant figures. Therefore, 1 mole contains Avogadro's constant, the number of units. So it could be atoms or molecules. So in 1 mole of, let's say if I had 1 mole of water, there's 1 mole, or there's Avogadro's constant, the number of, that's, let me start again. If I have 1 mole of water, right, there is Avogadro's constant, or Avogadro's number, the amount of water molecules. Therefore, if I have 1 mole of water, there's 6.022 times 10 to the power 23 water molecules in that 1 mole. So, or it could apply to atoms also. They sometimes try to trick you with these type of questions. They sometimes they'll give you a question where where you need to find out the number of atoms of a compound, but they'll give you the molecule. For example, if they say how many molecules are in 1 mole, so how many atoms are there in 1 mole of O2, some people might just go to say 6.022 times 10 to the power 23, whereas when you have to realize that oxygen is diatomic. So there's 6.022 times 10 to the power 23 oxygen molecules, but if you want oxygen atoms, it'll be 6.02, it'll be 2 times by 2 times by 6.022 times 10 to the power 23, because there's O2, so you have, and write it down. There's 6.022 times 10 to the power 23 oxygen atoms, right? If they're in one mole. Therefore, to get just oxygen in total, because it's O2, there'll be 2 times that to get just oxygen by itself. So just be wary of these types of things, because it could apply to molecules or atoms, but it depends on what they're telling you to work out. All right, concentration. A mole isn't very useful when dealing with liquids or solids. It's easier to deal with the volume of the fluid. So if going for solutions, right, it's easy to look at liquids and measure the volume. So you can go down here. So solutions. It's easier to look at liquids and measure the volume than to evaporate any water and measure the mass of a remaining solid. So if you just had like a solution, right? It's just gonna be so long to just, if you wanted to measure the mass of a compound that's dissolved in that solution, its concentration, right? That's the concentration would be the amount of solids that have been dissolved in that solvent. You could theoretically dissolve or so evaporate all the water from that compound and then weigh out the mass, but that's just so long and not necessary, and you probably end up with an invalid answer because some of your compound might evaporate as well. So that's not the best way of doing it. So it's much easier to look at it in this way. So you have a value. So a value is needed that lets us know how much of a solid is dissolved in a solution sample from its volume. If we know the concentration of a solution, if we get told the concentration of a solution, we can calculate the number of moles in any sample volume of solution. The concentration. The concentration is defined as the moles per unit, right? I think I said something wrong before. The concentration isn't the mass of your compound. That's wrong. The concentration it's kind of, it's a ratio. Concentration is the moles of your compound per given volume. That's your concentration. If you are given your concentration, the amount or they're giving you a way to work out your concentration, you can work out the moles. Once you have the moles, you can use that to work out the mass. It's just a lot of these questions that you have to use more than one equation to get your final answer, right? So concentration is defined as the moles per unit volume. The usual unit of concentrations are moles per liter, and liter is often written as decimeters cubed. So in your exam, it's always decimeters cubed. They never write it as liter. It's always written as decimeter cubed, which is just the same as a liter, right? Often written as moles per dm cubed. That should be a -3 here. Yes, moles per dm cubed. For example, right, if I had 3 moles of NaCl and they're dissolved in 1/2 liter of water, the concentration would be, so the concentration equal to the moles over the concentration equals to moles over volume, right? If I wanted to work out the concentration, be 3 over 0.5, and that's equal to 6 moles per dm cubed. Yes. Usually they don't actually give it to you as a liter. They'll say something like 500 milliliters or 500 centimeters cubed. By the way, milliliters is equal to centimeters cubed, by the way. But they'll usually say 500 centimeters cubed of water, and you have to verify. Don't say 500 centimeters cubed. It's always measured in decimeters cubed, so you have to convert centimeters cubed to decimeters cubed, which is the same as going from milliliter to liter. It'll be dividing it by 1,000. So if they give you 500, they'll usually give you 500 centimeters cubed, right? Times that, divide that by 1,000 to get 0.5. That's what usually you get. They never usually leave it as decimeters cubed. If they've already done it for you and left it as decimeters cubed, then that's already good for you. All right, mole calculations. In mole calculations, we can calculate the number of moles present in a sample of we can calculate the number of moles present in a sample if we know its mass and its MR. So if we have the moles, so if we've already worked out the moles, of course, so I can rearrange this equation, right, to get the moles. If I want to work out the mass and they asked me the question to work out the mass, I can rearrange this equation to give me the moles. Moles is equal to the concentration times by the volume. And once I get the moles, I can use that to work out the mass, right? So moles is equal to mass of the MR, right? And if I wanted to get the mass, just rearrange this to be mass is equal to the moles over the MR, and I've got down the mass. And same way we can calculate the number of moles present in a sample if we know its mass. if I want to work out the moles, there's another way of working out moles. It's just the mass over the MR. Maleic acid is, you have to be careful though with these questions. Like, maleic acid is diprotic, meaning it gives out 2 protons per molecule in solution. So if they gave you, I'll go on to this more, and this is more year 2 chemistry, or year 2, I think this is year 2 phys, yeah, year 2, acids and bases are year 2 physical, but if you get an equation, if they give you a question, there's actually 2 moles of your compound, you have to times it by 2. Right, so if I was working out the concentration, right, of an acid, and it's diprotic, we have to, and they'll say, how do you work out the concentration of it? You have to say, concentration is still moles of the over the volume, but it'll be 2 times. Sorry, it'll be 2 times over, because we have 2 H pluses. I'll go over this. This is more of a year 2 thing about learning about how acids, you know, what an acid is, how it releases H plus, dissociates H plus, but understanding this concept could apply to something else that's not even related to acids. Like, if you're just talking about something that's double, if you have an equation, you write out the equation, and in your products you have 2 moles of your compound, you have to take that into mind when you're, if you have 1 mole of it in your reactants, but 2 moles in your products, you've got to times your moles by 2. These type of things are important to understand. But other than that, the video's done. Hopefully this video helped.